In this video, we will focus on the one of the component in the cathode side, which we call it humidifier. So first, let's draw just a single stack. So we have a single stack. This is the anode. So let me anode, membrane, cathode. So we have the load here, we call it R. Okay, so as we discussed in the previous videos, so we know in the air side, so the inlet air actually before entered to the stack, so assume that this is the air come from the compressor. So this air enter to the humidifier first, humidifier enter to the stack, and the exit air as well goes to this humidifier and exit the humidifier. So we call let's say we call this side a wet side, stack exit is wet side, and stack inlet is dry side. So air here is the compressor. So and in this video we were gonna focus the humidifier and why we have to use this humidifier, or what is the reason to have the humidifier in front of the air that comes from the compressor side to the stack. So the reason that we use humidifier actually is to maintain the optimal moisture content in the air which enter to the stack. So then the question is why the amount of water content in the air is important for the stack. So actually as you know, the membrane, which is the most important part of the stack, and so we know that in the anode side the hydrogen molecules enter, and in the interface of the anode side and the membrane in the catalyst layer here, so the molecule of hydrogen breaks to the proton and electrons. So the proton, so let's call it proton. The proton cross the membrane, and the electrons goes through the external circuit, which is the current. So we use it to drive a car or drive an electric motor or whatever. And the protons cross the membrane and goes to the cathode side. And in the cathode side, so the protons plus the electrons and the oxygens, so they react and just produce water. In the cathode side, in the border of cathode channels and membrane, which is the cathode catalyst layer. So then the material of the membrane is normally it's Nafion, and it has the characteristics to conduct the ions, so protons, but it doesn't conduct the electron. That's why the electrons cross to the external circuit, but the proton cross the membrane. So when the air comes into the stack, has enough moisture, so finally we have enough water content in the stack. So this water content has some actually effect on the stack. So we will list all these effects. So if the air that's entered to the stack has enough water content, actually it prevents the membrane dehydrations. But because if the membrane dehydrates, so it is dry out, actually the proton conductivity decreases significantly, and this causes the performance reduce, and we have the potential damage, so we have less power. So that's why it's important to maintain the membrane enough hydrate. So the other reason is that if the membrane is dry, the proton cannot reach to the cathode side, so actually we have a higher resistance, efficiency reduction. So this is another reason that water content in the membrane is important. Other aspect that we can mention, and it's important, is actually it increased the lifespan of the membrane and actually the stack, because if we prevent the dry out of the membrane and protect it from degradation, so it actually increased the overall life expectancy of the fuel cell stack. It prevents the punctures in the membrane. So this is another reason that it's important to maintain the membrane enough humidified. And other important aspect is not just only dry out the membrane, it is important as well to prevent flooding in the stack, because flooding in the stack, because when it is high amount of water in the stack, so because the stack itself produce water, but this water is not enough to to hydrate the membrane, and the membrane has the best performance to conduct the protons. So if and the water content in the air actually helps to this water to maintain the stack in a best in a optimal situations. A huge amount of water in the stack, so actually it blocks the pores in the gas diffusion layer, which is here, because normally and it prevents the molecule of hydrogen to reach to the catalyst layer and participate in the reaction, and even in the anode side, because as you know, in the stack we have the channel, so then we have a layer which is we call it the diffusion layer, and the last layer, which is very thin, is a catalyst layer. So we have a channel, gas diffusion layer, and catalyst layer. In the cathode side is the same. So let me clean here to show you. So okay, let me draw here. So we have a thin layer here, which is the catalyst layer, a bigger layer here, which is which is gas diffusion layer, and this is a channel. Normally the gases used through the gas diffusion layer and reach to the catalyst layer to participate in the reaction in both sides, in the anode side and in the cathode side. So if there is a flooding in the stack, so these pores, this gas diffusion layers pores, will be blocked by the water, and it prevents the hydrogen or the oxygen to reach to the catalyst layer and participate in the reaction. Then we have like a gas starvation, performance reduction, and finally voltage drop and performance reduction. So that's why it's really important to maintain the air content, the water content of the air in an optimal value. But so the question is how normally there is a valve here, so different configuration could be used. So this is a bypass valve. So if we close the valve, actually all the air pass through the humidifier, and so the air has maximum the air that enter to the stack has the maximum water content. If we open the bypass valve, so the air goes to this side, and then the air that's entered to the stack is dry, so the water content is less. Sometime in some configuration the valve a bypass valve is used here. Actually normally a control valve here is used, so to bypass the wet air. So in this way we can control the amount of water that's entered to the dry air. But how this water entered? Normally if the humidifier is a membrane humidifier, in a membrane humidifier, so assume that this is the humidifier. In the membrane humidifier, so we have a thin layer which is a membrane actually. So let's say the air from compressor enter here, exit here. So the air from the stack enter here and exit here. So if we call it dry in, dry out, so this is wet in, and this one is wet out. So through the membrane that is inside the humidifier, the molecule of water, due to gradient of water, because this side is less water and this side the air has more water, and due to the difference in gradients, so the molecule of water passed through the membrane and goes to the dry side. That's why the air that's entered to the humidifier is dry, but the one that exits from the humidifier from the dry side has more water content, and the more this water content from the wet side passed through the membrane and goes to the dry side. And here the dry air has enough actually water content. So that's why here in this configuration we can control the amount of wet air that enter to the humidifier by this control valve, or we can control the dry air through this control valve. So in this way we can control the humidity inside the stack. But sometime so the information that we have to use to control the humidity, sometimes there is a humidity sensor here actually, or sometimes we use the dew point, because the relative humidity it depends the sensor. The sensor gives you relative humidity or dew point temperature. So the relative humidity is a variable that depends on the temperature. So that's why some majority of time it's better to control the humidity ratio, which is the amount of water that exists in the air, not the relative humidity, because the relative humidity depend on the temperature, but humidity ratio or dew point are the better variable that we can use to control the humidity of a stack. In a separate video I will explain by detail how we can use the dew point and why we use the dew point and humidity ratio to control the humidity. In this session just we wanted to focus more why we have to use a humidifier. Of course as I said, there are many factors or many many variables that we can use to identify that the stack has enough humidity or no. So the main one is CVM, or cell voltage monitoring. Through monitoring the cell voltage, we can have information about the stack humidity condition. So thank you so much. Don't forget to subscribe to be notified about the next video about the fuel cell system and all concept about the fuel cell system, how it works,